Okay, let's have a look at what question 7 is. A uniform rod BC of length 3 has a mass 20. The end B, which the rod can turn freely, is attached to a vertical wall, so it's like some kind of hinge. The rod is kept in a horizontal position by a rope attached to point D on the rod and point A on the wall vertically above B as shown in the diagram. AB is H, which is not shown. AB is H and BD is 2, which makes this side root H squared plus 4. And I can already see that's in the result for the tension in the rope. So let's draw that. So you have your rod here, and we actually know the rod's length is 3 meters as well, which is not shown. Is that H meters? Yeah. And meters there. Okay, so straight away I know that bang in the middle here is a 20G force. So that's 20G. And then at 2, now that's 1.5 meters. Then at 0.5 meters, here is where the rope connects, and then that last bit there is 0. No, it's not. It's 1 meter. It's not really accurate, is it? Let's extend that a little bit more. Okay. I could have drawn this a bit more accurately. Okay, 1 meter then. So 1.5 to the middle, and then another 1.5 to the end. And it's 2 meters to where the rope is. So the rope is along this direction here. There's a tension here. And then there's a reaction at the hinge here. And in fact, due to Lamy's 3-force theorem, I know that the reaction points exactly here is where these lines intersect. So that's the force picture here. Yeah, so I can start resolving now. I mean, we could now, or do I even need to resolve actually? Because I just really care about this component here. I don't really care about that component because I'm going to take the hinge as a turning point to get rid of the or. So if I call this theta, then this would be t sine theta. So I have then that 2 t sine theta, that's the anti-clockwise moment about the hinge, that should equal 1.5 times 20G. So that means t sine theta equals 15G, because I can cancel 10 down to 10 and make that 15. So I can get t is 15G over sine theta, and sine theta is opposite over hypotenuse. So that's 15G H, and then root H squared plus 4. I'm assuming 15G is 147. I mean, it seems like it should be, shouldn't it? Because G is about 10. So might as well check on the calculator. 15 times 9.8 is indeed 147. 147 root H squared plus 4 over H. Does that match up? It does, and we're happy. If the tension in the rope cannot exceed 245, show that H must be more than 1.5. So this is really just as simple as setting this equal to 245 and solving. Let's make a bit of space. I shall multiply by h, or let's make it an inequality. So has to be less than or equal to. So 245h is less than or equal to 147 square root h squared plus 4. So divide by 147, you get 5 over 3h less than or equal to square root h squared plus 4. So that's 25 over 9 h squared less than or equal to h squared plus 4. That means 16 over 9 h squared minus 4 more than or equal to 0. So that means 4 over 3h minus 2 times 4 over 3h plus 2. That must be greater than or equal to 0. So I'll just make a bit more space up the top here. So we have a negative and a positive, and we have a solution here and a solution here, but since h has to be positive, we have this point here, that would be, oh, actually, you know what I can do? I can divide by 2. I should have done that earlier. So divide by 2, divide by 2, divide by 2, divide by 2. So that becomes 2, 1, 2, 1. So this one here is minus 3 over 2. And this one here is plus 3 over 2. So we want to go for that solution there. H is more than or equal to 3 over 2, meaning h is more than or equal to 1.5. I'm very happy with this question. I really like that it was a show that twice and we can know that we got the answer right. So we should be very happy with this question. It's a nice question.